Good morning, friends. We are starting this course, Introduction to Soil and Water Conservation. This class would be an introductory class. Let me introduce myself. My name is Dr. Mintu Job. I am a faculty in College of Agriculture Engineering, Department of Agriculture Engineering, and I am here since last 15 years. So this course, today's will be an introductory, will give an overview of the soil and water conservation. Soil and water conservation, I think you must be aware of. It goes in the same line as heat and mass conservation. Here we try to conserve two very important natural resources, that is soil and water. And soil erosion is one of the very major component of this soil and water conservation, because it directly deals with diversity, it directly deals with ecology, and it directly deals with production. When we talk about production, agriculture production, and again this livelihood, rural livelihood. So coming to soil erosion, this soil erosion derives from the Latin word erodere. Erodere means eating away or detachment. So, in the same line, this word has been coined for many other geological terms like corrosion, abrasion, or denudation. So these all things can be used in the same sense. I have designed the course, this introductory chapter, in such a way that we will be discussing about what is soil erosion, what are its classification, what are its type, and what are the causes and effects of soil erosion. And this erosion is not a new term for us. Most of you might have studied soil erosion in the elementary schools, maybe class 9, 10, 11, 12. So this erosion, soil erosion, has become very prominent subject. You study in life sciences or in physical sciences. So this erosion is also not new. It's as old as our civilization. The great Indian civilization like Mohenjo-daro or Harappa culture, there is remnants of soil erosion. The great structures that we see in Mohenjo-daro, that is a result of gradual erosion of the soil, that top soil, then we get beautiful structures. And also soil erosion also deals with many adverse processes which which has got the potential to decrease the your productivity. Now coming to our slides, when we talk about the importance of soil, as we know, soil is one of the most important natural resources because many habitants live there. It gives support to plants. It is a base for your nutrients and minerals. So soil in itself is a very vast thing. And it also gives medium to the plant for nutrition, for storage of nutrition, for storage of water, which is used by the plant in the process of its food making. And it's also habitat for many microorganisms, many harmful, and also the organisms which are very useful to survival of any living species. It's a habitat for many organisms. And also we all know it gives support to our food requirement by anchoring our root system, and also many other non-food things like building structures. It gives a foundation to many structural activities also. So the importance of soil is paramount. Talking about the present status of soil erosion, around in the world scenario 75 billion tons fertile soil are lost as a result of soil erosion. Erosion, as we know, is eating away of the soil through some erosion causing agents like wind and water. Coming to Indian scenario, around 5,300 million ton of fertile soil, which is almost equivalent to 51% of your cultivated land. Our cultivated land is around 180 million hectares, out of which around 88 million hectares is affected by directly or indirectly with soil erosion. So the question will come, what are the causes of soil degradation or erosion? First cause is extensive farming, because maybe 50 or 100 years back the farming was not so extensive. Because of the pressure of population and the industrial growth, the farming has become very extensive. As a result, it has affected the production system. See, any system has got a carrying capacity. This carrying capacity has been challenged by this too much use of by utilizing soil and other inputs very much. Second is the denudation of the forest or deforestation. Because of greed, because of rapid industrialization, or because of quick profits, we have cut our forest or we have deforested our land, and this has affected the ecology in a very, very bad manner, and this is one of the very major causes of soil erosion. Again, the intention of growing, making quick profit through excessive use of fertilizers and pesticides, this has also affected your biomass production, because for a short term you will have very high yield, but it will definitely have adverse effect on the soil and the environment around it. These are some of the causes of soil degradation. So what are its effect? So if its effect can be seen in many ways, directly or indirectly. If you talk about the seashores, lakhs of hectares is being lost because of soil erosion, because of cutting away of the soil in the seashore, which is very productive as far as agriculture is concerned, and also as far as industry and commercial, it has got a very high commercial value. So large amount of land, large amount of your structural activities are lost because of this soil erosion. And second, it has also got health hazard associated with it, because once erosion starts, flooding starts, because your capacity of your river, canal will become less because of deposition of silts from the upper side. As a result, what happens is your capacity becomes less and the area is inundated by water, and we all know it's a known fact that whenever there is more moisture, humid conditions, bacteria, these viruses will spread, and there will be huge cost in terms of health. So the health hazard is also indirectly related with soil erosion. Then again, you have the lessening of capacity of your canal irrigation projects. There can be many things. Migration, for example, is associated with soil erosion, because once your land is less productive, people will start migrating to other places in search of greener pastures, and since there is less they can produce in their land, or they are not able to get prices for their produce. Now the question comes, why we need to conserve soil? Because soil formation and your erosion is a continuous process. The soil formation itself is an example of soil erosion, because hard rocks wither because of climatic variations. It wither at a rate which is if it is equal or more than less than the rate of production, then you have a healthy growth, healthy soil formation. But if the withering, if the formation of soil is less than the formation, erosion of the soil, then the problem starts. Then we call it accelerated erosion. It takes around 8 to 100 years for 1 centimeter depth of soil to be produced or deposited on the soil surface, land surface. If you see the soil profile, if you have a cut profile of the soil, there are many layers like A layer, B layer, in scientific term we call it C layer, D layer, or we can also have denotation like column 1, 2, 3. The top you see 30 centimeter, that is the most productive, nutritive, where the plant grow and take the nutritions from. And below that layer, underneath that layer is your subsoil, which is little harder. Some root canopy penetrate into it. Some crops, shallow rooted crops, does not. And underneath that layer is the parent material, and the last is your bedrocks. If you see this is a field figure. You see the upper layer, then you subsoil, then your parent material, and this is the hard soil. And the process of formation is parent material, it gets withered because of the prolonged biological, chemical and physical activity. You have the formation of soil. This figure I have put purposely to show you. This is a typical country land, especially when you talk about place like Jharkhand, we have very undulating topography. Typology of the land is such that in the upper reach we have forest, then we have upland, then you have homestead area where maximum of the activity, livestock, your human habitation take place. Then we have the medium land, low land, then after that we have a water bodies. This type of feature we will find in places our Chota Nagpur plateau. So this forest land, this upland is more susceptible for soil erosion because the slope is more steep, soil depth is less, and the texture of soil is such that you cannot have very good crop. You have to choose the crop for such type of land, and the availability of water is also very less in such type of land. Then we have this medium land and low land where most of the production takes place. We have to conserve both uplands, medium land as well as the low land, taking into account the environmental impact as well. We have just talked about the two types of classification of erosion. One is the geological erosion and second is the accelerated erosion. We have also discussed geological erosion is the natural form of erosion where the soil formation, rate of formation of the soil is more or equal to the rate of degradation. Such type of system is very healthy. We consider it very healthy because the formation is more. In such type of system we don't have soil erosion. Problem comes in the accelerated erosion or the man-made erosion. Because of some man-made reason, the rate of production, rate of formation of soil is less than the rate of depletion or rate of erosion. In such type of land we have this accelerated erosion, and when we talk about soil erosion, we talk about accelerated erosion. And of course the rate of formation of soil is very slow in this process. In accelerated erosion, the rate of erosion would be little faster. Now exactly what is soil erosion? It is the process of detachment of soil particles from parent body or the surface of the soil and its transportation of the detached soil particles to one place to another. This is called your soil erosion. That is, you have two things, detachment and transportation. How does it occur? It occurs because of two erosion causing agents like wind and water. So this is the mechanism of your soil erosion: detachment, then transportation. Detaching agents are raindrops, channel flow, and wind, and the transporting agents are flowing water and the wind. So there are two main types of erosion, or we can also call it the classification. It's based on the agents: water erosion, and second is wind erosion. In India, most of the erosion we are talking about some data around 88 million hectares. 70% of the erosion is caused due to water erosion, and wind erosion is more pronounced, more prominent in areas like arid or semi-arid areas like Rajasthan, Gujarat, parts of UP and Haryana. In such places where the wind threshold speed is high, there we have wind erosion. But mostly the erosion takes place in India through water erosion. And there are 5 common types of water erosion, and each type is a advanced form of the other type. We have 5 types of raindrop erosion, then sheet erosion, then rill erosion, then gully erosion, ravine erosion, or stream bank erosion, or landslide is also one form of erosion. We will deal each one of it in detail. As the name suggests, these are the two agents: water and wind. This raindrop erosion, or we also call it the splash erosion. Splash erosion occurs because of the impact of raindrops. Wherever the raindrop is more than 0.5 mm, there is every chance that when it falls at a certain threshold velocity, it would disturb the soil particles. And we also call it splash erosion because the soil is somewhat disturbed from its parent material. So this impact, we call it the raindrop erosion or the splash erosion. Splash erosion does not in itself carry away the soil. It just disturbs the soil particles or detach the soil particles or loosen the soil particle from its parent body. See, this is the impact of slash. The dislodging of soil particle by raindrop impact is primary cause of surface irrigation. So what happens once the soil is disturbed or dislocated from its parent material? Then what happens if rain further continues? What happens is this dislodged soil particles is carried away through the rain flow. There would be at many places, because of the impact of the raindrop, soil particles would be loosened, and that loosened soil will be carried away from one place to another, and such type of erosion is called sheet erosion. And sheet erosion is considered, although it is very mild form of erosion, we consider the most dangerous form of erosion. Why? Because when this type of erosion occurs, the farmer or the stakeholder is not able to gauge what is the extent of erosion, because without your knowledge a layer of soil is removed from the parent material. So such type of event occurring again and again will remove a considerable depth of soil from your parent material. So this you can see from the pictures. See, some sheet of soil is removed from the soil bed. Now, as sheet erosion continues unabated, it takes the form of small minute channels. जैसे आपका शीट इरोजन उसके जैसे कंटिन्यू होगा, ये छोटे छोटे नाली में ये चेंज हो जाएगा, and it will become a carrier to your वाटर फ्लो, और उस नाली से पानी बहना शुरू हो जाएगा, और उस the streams will widen and deepen over the period of time. और ये this rill erosion is a advanced stage of sheet erosion, as sheet erosion is advanced stage of raindrop erosion. तो इस तरह से this way you have rills or small gullies which is a conduit or carrier of large amount of rainwater. So this is, we call it the rill erosion. Now again, when rill erosion is continued, where we do not take any precautionary measure in the rill erosion, the rills will develop both in depth as well as in width. So this will take the form of a gully. So it becomes a gully erosion. It is the advanced form of rill erosion, gully erosion. So most of our soil and water conservation measures are focused to control the gully erosion. It is one of the most severest form of erosion. See, this gully erosion, again, it starts from a gully head. Whenever there is an impact of rainfall, it will form a small gully head after continuing with the rill erosion, and this gully will continue its length as well as it will deepen. So it's a larger form of rill erosion is your gully erosion. Now this ravines is something which cannot be controlled. Such type of ravines we can see in the Chambal Ghati in Rajasthan and borders of Madhya Pradesh. This is the more advanced form of gully erosion. Gully erosion not controlled, it becomes ravines, take the shape of ravines. And when your land take the form of ravines, there cannot be any solution to it. Any economical solution उसमें नहीं हो सकता. यदि आप उसको कंट्रोल भी करना चाहे तो वो इकोनॉमिकली वायबल नहीं होगा. This type of feature is very common in hilly places, terrains, जहाँ पे आपका road बीच अंदर से there is undercutting of soil underneath the soil and the large chunk of land is removed. This is a natural disaster. We call it landslide. Sliding down of large chunk of soil due to combined effect of steep slope and prolonged rain. There is another form of erosion, we call it stream bank erosion. This form of erosion occurs when sides of your banks gets undercut and there is widening of your river. Such type of erosion we call it stream bank erosion. This is a special form of erosion. Now we have discussed about different types of erosion. Now comes what are the factors which are influencing soil erosion. We will go just glide through it. We won't go to the details as today is the first class. The factors influencing soil erosion can be mainly enumerated as rainfall, vegetation, soil, man and animal. So, when we talk about rainfall, its duration, its amount, as well as most importantly its intensity is very important. Intensity, what is it? Intensity is the rate of rainfall, rate at which rain falls on a particular place. Say 5 centimeter per hour. That is total depth divided by the time. So it will decide the rate of erosion. How? Because if there is an intense rain, the impact of raindrop would be more. Also, the rate at which the infiltration occurs in the soil would be less than the rate of rainfall. Then what will happen? The excess rain will be moved from one place to another and it will join any stream or a river. So in this process what will happen is it will take away the top soil or the nutritive soil. There would be a migration of biomass, there would be migration of water and there would be migration of soil particles from one place to another, and this soil will be deposited in some lower land, lower field, or in the canal, thereby reducing its capacity. So rainfall is one of the most determining factor of soil erosion. We will be dealing with this in separate classes, coming classes. Second is vegetation. What is the effect of vegetation? If we compare two type of land, one which is a bare soil, another one which having some vegetation, what will happen if we think logically? The bare soil will be susceptible to your rainfall impact. It will be susceptible to your excess rainfall, runoff. In vegetative condition, what will happen? This vegetation will interfere with the impact of rainfall. It will intercept the rainfall. Thereby, the impact of rainfall on the soil, which is underneath, will be less. From a vegetative land, the erosion would be less, and compared to a bare soil. Also, the plant height is also a determining factor. If the intensity or the speed of impact of rain is stopped at a certain height, then it will fall at a lower intensity. So, more the plant height, less will be your soil erosion. Then soil also plays an important role. What is the type of soil? If you have coarse soil, heavy soil, the impact of rainfall will be, because the soil particles will be more binded together, and the detachment, the force required to detach the soil would be more. So it will remain intact. If a loose soil like sandy type or sandy loam type will be more susceptible to soil erosion. And also texture and structure of the soil is also important in this case. Topography is one of the very important factor. If the slope is more, naturally water will flow at a very higher rate, runoff will be flowing at a higher rate. And also man and animal, if there is excessive farming, if there is uncontrolled grazing, such type of land will be affected by soil erosion more. So what are the losses that we suffer due to soil erosion? The rainwater, which is very precious, which we are supposed to conserve, is lost. The very concept of water harvesting cannot be done economically, so there would be loss of this very important natural resources which we cannot tap it, which will go as waste. Second is loss of fertility. We had mentioned earlier that in any area landscape, there is a migration of soil, water, as well as the biomass. This fertile soil which is there in the top 30 centimeter, this soil is moved from one place to another. So the fertility of your place also reduces. Fertility and nutrient losses is also directly linked with it. And siltation of reservoir. If we have reservoir, rivers or canal, what happens? The sand from the upper reach will come and get deposited in the reservoirs, and thereby reducing its capacity. Once the capacity of reservoir or canals is reduced, even a very small runoff, even a small rainfall will cause excessive floods. So this is, then again there would be health hazards, and there would be many more problems associated with it, both social and economical. We'll just touch upon this wind erosion. So erosion by wind is common in dry areas, especially in arid and semi-arid regions. In India, it comprises of around 23% of the total erosion that is taking place. So I have tried to animate this figure. This wind catches the organic matter, clay and silt, and then blows away them. This figure, we can see this is a maize area cultivated with maize. This place is subject is figure of somewhere in Rajasthan. So because of wind erosion, there is uneven soil depth and also uneven soil nutrient level is also very uneven because of wind erosion. So if we combine everything in one picture, we can see the wind erosion, then it's raindrop erosion. What is the effect of raindrop erosion? It separates the soil particles from its bed. And once raindrop erosion or splash erosion continues, and if rain falls at a rate higher than infiltration rate of the soil, this scattered rain, these soil particles will be moved away from one place to another through sheet. Entire sheet of land is removed from the soil surface. Then if it is not controlled, it will form a small gullies. Then gullies will convert into rills. Rills will convert into gully, and ultimately stream bank and ravine erosion will take place. This is the entire process of your soil erosion in one figure. And each stages, these are the different type of water erosion. Each stage, from stage 2, stage 3, 4 and 5, this is a advanced stage of the previous one. Like rill erosion is the advanced stage of sheet erosion. In the same way, sheet erosion is the advanced stage of raindrop erosion. So this figure I think we will be discussing sometime later. This figure, this is a production system. Initially we are talking about the carrying capacity of a system. Everything we live in a system. So we have divided this into 3 time zones. Time zone A, time zone B, time zone C. And this dark line is the potential of the system. And this dotted line is the exploitation of the system or the production. See, time A, at time horizon A, maybe 100 or 150 years ago, then the system, our system had, the potential was very high, but its utilization was less. So the system was intact. As we came to the second horizon, time horizon B, due to industrialization or rapid agriculture, or maybe 50 years back, we are talking about 50 years back, slowly our exploitation started increasing. But our exploitation started increasing more than the potential of the system. Still the potential was intact because of the internal mobilization of resources. Like if we, for example, the loss of biomass was compensated by using bushes as vermicompost making, such type of things happened. So the system was intact even though the exploitation was more. But the time horizon C, at the present time which we are living, maybe in the last 20, 30, 40, 50 years, what is happening is your exploitation now, this comes at the apogee of this graph curve. Now your utilization starts decreasing. How? Because there is, and as a result your potential also is decreasing, because there is nothing much to be exploited, because your potential is reducing, and as a result you are not able to exploit as well because you have less potential. So this type of system and this type of system we have to address to, where the carrying capacity of a system we are challenging by overutilization, because we are not paying attention to conservation. So in conservation, 3 things are very important. Conservation, regeneration, we should always allow regeneration of anything. If regeneration is not allowed, such type of system will occur. Say for an example, you have a small field of 50 hectare grazing land. It is designed for maybe 200 cattle, but if you increase the number of cattle, more cattle are grazing, it will not allow the system to regenerate. The pastures will not regenerate. As a result, what will happen? There would be loss of biomass, there would be loss of fertility and loss of everything, and loss of soil erosion will be there. So that's all from my side today. We'll be discussing in the forthcoming classes. We'll be discussing more and talking about soil erosion, its history, the efforts in terms of soil erosion. We have started from the first 5-year plan itself. There were one research institute at Jodhpur, desert, Kajri, Jodhpur, that was intended to increase the soil fertility through soil and water conservation. And later in the second and third 5-year plan, there were 5 training institutes, soil and water conservation training institute with its headquarters at Dehradun, and 8 regional centers. They have started working on many soil and water conservation works, initially for bunding and terracing. Then later on they expanded its purview to many other activities, social as well as technical activities related to soil and water conservation. So things are moving, and of late we have started with taking the entire area as a watershed development program. For the last 20-30 years, such type of program is going on and taking place. Some effects are being seen, and hopefully things will the issues regarding soil and water conservation will be addressed. And as far as our course is concerned, we will go topic by topic in the coming sessions. And that's all for today. Thank you.